Hi, okay, so let's go through the weekend paper too. So let's take a look. So look at the question, you see something very interesting. This thing, 13.6, has a lot of numbers. This shows you 3 sig fig, which is honestly very rare. Can they do this to you during exam conditions? Yes, it is possible, but it is rare. Typically, 2SF is the common one, at least in physics. Alright, okay, so but in this case, this particular segment is 3SF, so we give them our final answer in 3SF. So it says mass. So what do we have here? We have density, mass. So if you recall, your formula here is mass equal to density times volume. So in this case, what do we have? We have density 13.6 gram per cm cube times volume. The volume in this case, do we have the volume? We have the cross-sectional area, which is 0.4 times 2, which gives you a final answer of 10.9 gram 3SF. Okay, actually, if I'm not wrong, you will get 10.88 gram, 10.9 gram 3SF. So the 3SF, I repeat, is only for this particular question because they give you one of the numbers in 3SF. Normally 2SF is fine, don't worry about it. Okay, next part. So it's like a trap. This is 10 Newton per kg. But previously we have found out in gram. Oh no, this is a trap. So you should have come across enough, right? Enough questions that some of these traps are essentially just units, the magnitude. So formula there is W equal to mg equal to m, which is 10.88. Do not use the rounded off answers. Oops. Do not use rounded off answers to continue the next part. You use the original number. So the one highlighted in green here tells me that use original number in a not rounded off number. Anyway, times 10, which gives you, this is divided by 1000. You should get an answer of 0.1088 n, which is 0.109 n 3SF. 3SF because of this very specific question. Next one, pressure. P equal to F over A. So in this case, the force, which is your weight 0.109 divided by 0.4. 1088. 0.273 Newton per cm square. 0.273. Yep. Okay, next one would be this. Okay, so first read carefully. So they say the person jumped off because skydiving, right? Skydiving. So look at what they are saying. A long time after jumping, you become this thing called constant speed. But it's after a long time. So initially, when you jump, you barely have any speed, I guess, to begin with. So the main thing that's accelerating is actually your 10 meter per second square, which is essentially your g. What are the forces here? So from the middle downwards, this is your weight. Same also about the middle, go up, this is your air resistance. Next portion, they ask you state the time when it opens the parachute. So you just look at the graph and figure out. 12. So the answer here is 12 seconds. Don't waste. Remember the units. State the type of acceleration. So it is actually your zero acceleration. So the zero acceleration is supposed to relate the weight and air resistance. So what happened is basically that the air resistance is basically equal to the weight. Air resistance, weight is the same. Because this will result in no resultant force. Recall F equal to MF resultant equal to MA. So if there's no resultant force, that means there is no acceleration as well. That's why earlier on they talk about it being constant speed. Constant speed means there's no acceleration, which means there's no resultant force. Okay, part C asks you to find distance. Very simple. Look at the graph. We have a speed time graph. If you recall, I written down this before. Gradient is basically y-axis divided by x-axis. So in this case, it's a speed divided by time. You get acceleration. So gradient is always the y-axis divided by the x-axis. Then you have another one, area under the curve. Is basically the y-axis times the x-axis. Which is in this case speed times time give you distance. Oh, question asking for distance. Oh, so it's just the area under the curve. Yep, so the distance here is basically the area under the curve. Under graph, under curve, whatever you call that. Which is just 54 times 10 equal to 540 meter. Units. Other than that, pretty straightforward. 1D is your describing motion. If you don't know, okay, if you recall, I said before this is the type of question that students don't do well, but it always comes out one the motion. So motion can refer to two things. First thing is usually the speed. If it's the speed, right, this one you need to code the number because your graph got say. Second thing that comes along is your acceleration. In the graph, it's not in terms of acceleration, but we can find but not needed. So for acceleration, I don't need a number to go per se. So first we'll say that there is a decreasing deceleration when from time equal to 12 seconds to t equal to 27.5 seconds. So that is, so you see, I did not give a number for the acceleration itself. Speed wise, yes, it travels at a constant speed. 27.5 seconds, 27.5 seconds. That is like a 4, 6, 8, 10. Constant speed of 8 meter per second. (27.5 seconds to your 30 seconds. Yep. Okay, next one, your liver. Not heart, not lung. Okay, joke. Yes, how do you do this liver question? Let's take a look. So, you're supposed to explain how the design. So you look at this, the topic that comes to your mind is called moment. It comes to your mind in this moment. Yeah, so what happens? Let's take a look. Wow. Realize the perpendicular distance is pretty far. So the idea is, first thing I'm looking out for is the effort. Basically, your hand we call it effort, is far away. Don't write further away, it's far away from the pivot. Like literally one end to the other end. Yeah, so the effort is far away. Effort, which is your hand, is far away. This will result in you to use a smaller force to, so the second point we're looking out for is, as a result, you require a smaller force. This smaller force is to actually basically achieve some form of clockwise movement. I mean, you want to crush a can, you have to move down, so it's a clockwise movement. Yeah. So what are the forces here we're looking out for? First, the force is here. Okay, it seems like you are pressing down on it, so that's one force. Second force will be, see the can going upwards to this segment. It's like an action reaction force thing, see. Okay, next calculation. So don't panic, let's take a look. It says, I mean color code, color code. Downward force of 50 Newton. Isn't this your downward force? So this is your 50 Newton at the handle, which is there. Calculate the force. So it's just a straightforward force. Formula here will be, so how do we do this? So 50 Newton times 0.5 equivalent to the force on the can times 0.2. It's like the clockwise moment and the clockwise moments, they must balance out in that sense. So in this case, after simplifying, you realize the answer is 125 Newton and approximately 130 Newton to SF. Very good. So pressure, P equal to F over A. Just throw in the formula. So 125 A. The A here is pi involved. So 3.14 times 0.03 square. So again, trap here, this is a trap. Radius, which is length is supposed to be in meter. Therefore so it's a very standard thing that they have to do 44232, which means you get 44000 Pascal 2SF. Is it 2SF? Let's see if they have given any other things that's 3SF. Nope, majority are 2, if not 1, so it's fine. Yep, that's about it. Thank you.